Do a countdown.
Should we start? Okay. Okay. Good morning, everyone. 9:30 is time to start our session. We are in the NASR BOF. NASR stands for Network Attestation for Secured Forwarding. Slight change in the meaning of the acronym. We will go over it. I'm Luigi. Here nearby is Nancy. We are co-chairing this session today. Okay. The usual note well. You are supposed to have read this during the registration. Very, very short summary means that everything we say and we share here today is a contribution to the IETF. And if you know any IPR that applies to what we discuss here, you are supposed to share this knowledge with us. Another part of the note well is the fact that we are today here to discuss technical issues and problems and formulation, and so we treat each other with respect. For people remote, I guess they already logged in the remote Mitico tool. For people that are here in the room, please scan the QR code and log in the on-site Mitico tool, please. You know, this counts for the blue sheets and is also important when you queue up to ask questions, and we have a quite room to have a Q&A discussion today. Okay. These are the usual pointers about everything related to this session, the materials, the minutes, agenda, etc., etc., etc. Okay. Antoine Fressancourt gently volunteered to take the minutes today, but if anybody wants to help, we on the Etherpad, please feel free to help him. Oops, too much. So this is the agenda today. We are through agenda bashing. We will spend one slide explaining a little bit the timeline on why we ended up here this morning. Okay. And then we will jump into the technical discussion with Diego covering the use cases. Okay. And later on, problem statement and proposed architecture covered by Peter. Okay. Now, we decided to change a little bit the order of the agenda. So right after the technical presentation, we will jump to the open mic session because we want to make sure that everybody is on the same page, that the technical issues are clear enough for everybody and well understood, okay? Otherwise, there is no point in discuss a charter if we are not all on the same page. So we will open the mic right after the technical presentations and then go over the charter discussion, okay? And to conclude, to explore the consensus and the next steps after this both, okay? And that's it. Concerning the agenda, anybody has any comment on this? Seems not. Okay. So why we are here today? This is actually the achievement of like more than 1 year of work. Everything started in IETF 118 with a side meeting on path validation. This was back in Prague. Then there was another side meeting with the acronym NASR, which at that time stands for secure routing, okay, in 119, and which lead to a first BOF, okay. There was good feedback during the first BOF and after the first BOF. A lot of feedback, so we had to work it out, okay. So that's why we didn't went directly for a second BOF in 121, okay. We had just a side meeting, But between 121 and now, we spent quite some time in several interim meetings with an interval of 2 weeks, more or less. So we discussed the scope, the charter, etc. The slides we prepared as really a community effort, even if we cannot make everybody present, but there is a good participation. So, and the goal today, which is to check whether or not all this effort can result in a working group forming, okay? And if the charter that the community worked on is clear enough, obviously there are adjustments to be done. I mean, nothing is set on stone, okay? But more importantly is the fact that we all understand what is the problem and have an idea on how to solve it, okay? A direction where to go, and that this is solvable in the IETF, okay? And that we have a critical mass of contributors. It already seems so, but let's not go ahead, okay? I have a strange delay in everything that I do on my computer. No, seems to work. But anyway, now the floor is to Diego. Come up, I will share the slides. You can take the clicker, I will give you control.
So the idea is to show you the main use cases that are more of the, let's say, the use cases of reference that we closer. Well, anyway, that makes me bend, but anyway. The use cases of reference that we have been discussing in the while trying to shape the idea of NASR, and which are the implications. We have tried, there are a few scenarios, and I tried to generalize things in terms of, well, defining how policy and how with NASR goals we can show how network policies can be matched. The archetypal use case, and this is something that we have shown once and again, and it comes from the Sion community, is about this case of the Geneva-Sion connection in between in the zone that is around if I'm right, that's Lac Léman, in the middle of France and Switzerland. For those of you who have been there, Geneva Airport, for example, has two doors, one to France, the other one to Geneva, and is in an interesting situation of multinational, very multinational environment. And the case that, Swiss banks, as you know, have a fame of being extremely careful about their procedures, the integrity of data and privacy of their consumers, customers, sorry. So in a case that you have this Swiss bank that has some offices in Geneva, some others in Sion within Switzerland, but the shortest path physically and very likely in terms of the network as well would be what you have there, that crosses France, which is something that according to the policy of the bank, and very likely, I'm not familiar with the Swiss bank legislation, but very likely according to the legislation there is something that cannot be done. So the policy for this connection would be precisely what you see there, which is illustrated physically mainly, but let me say it's the integration of the network there, as the integration of the airport is very high. So the other path that seems much more convoluted physically would be convoluted as well in terms of the network, would be the correct one that is following the required policy of the bank. The point is that you can for sure establish routing, etc., but the customer, and this is something that is important, the customer cannot necessarily verify that this is being enforced. But with the mechanisms that we have for NASR is not only, or that we propose for NASR, is not only that you can define the path and verify in advance that everything goes as expected in terms of physical location, that data is not leaving the Swiss territory at any point, but as well that you are traversing routes, routers and systems that are according to a particular security profile. You set this in a way, but it's as well that you can verify once the path is established that that if things goes following the shortest path that the network would facilitate, you will have you will get a warning, and in other cases you can verify as well that packets, individual packets, are going in the path that you're following. So let me say, it's not only about implementing the policy during the deployment of the connection, but this as well to allow the users of the network that this is being followed. I don't know. We have someone at the mic, I don't know. This person. Yeah, I'm not using my glasses, and so.
Oh yeah, it's okay. So hi, I'm Richard Barnes from Cisco. So you're talking about this in terms of network path and assuring a given network path, which is a bit in tension with the end-to-end principle. So I wonder why you could, if you could elaborate a bit on why this is important to assure at the network layer, as opposed to assuring that the endpoints involved in this are connecting and assuring the right security properties end-to-end.
Again, is something that has to do with the path. We are not making any about the, and there has been a lot of discussion in the on the list on whether this is trying to substitute end-to-end encryption or whatever. It's not. We are not making any assumption. The same way that when you're doing end-to-end encryption, you are not concerned with the path, because you're supposed to. The path can be anyone as long as you have the end-to-end encryption properties. Here is the same. I mean, end-to-end encryption. This is not trying to substitute end-to-end encryption by any means, just to fulfill particular policies that you want to impose and verify on the path.
Let me try and state the question a little bit differently. The practical, the underlying requirement below all these path requirements you've listed here is denying the French access to my traffic.
Is not passing through France because your bank.
Why do I care if it goes through France? Because I want to deny the French access to my information.
Because the Swiss legislation requires so. It's simply like that.
Carlos, do you want to?
Do you want me to? Oh,
worst case, you're ending up with it's a regulation, right? And if you're trying to fight national or international regulation, why are you not just trying to make money as a network operator, right? But of course, we can go into all the different terms of security and how even end-to-end encryption is attacked on the hosts, right? I mean, there are pervasive attacks against them, right? Exfiltration of keys.
Torles, I think again I have to get closer to the mic.
Sorry. Yeah. I mean, we all love the end-to-end encryption principle, but it's not the perfect and solves everything solution, right? And a lot of operators and especially regulators are worried of equally having whatever are considered to be the best factors to create a safe network, right? And not going through other territory is one of the very common expectations and regulatory requirements.
Just to, I'll add one more note, now then I'll let this drop. But if we're talking about regulation, it would be good to be concrete in what we're talking about here, to kind of list at least some examples of actual requirements, as opposed to imagining, that there could be regulation of a given flavor. So, okay,
yeah,
great,
so,
cool. I will look forward to seeing that.
They appear at the end. They appear at the end, I promise.
Jeff, I'll keep this brief. The term you're looking for here is data sovereignty. And as it's been said, this is a regulatory thing. So we're happy to say that this is one of the use cases. Thus far, I don't think you've actually hit why what we're looking at for this BOF actually covers that use case.
Basically, let me say one thing. What we're talking here is about network users' requirements. They come, in this particular case, and well, in many others, they may come from regulatory, and again, not from network regulatory matters, but maybe for banking regulatory. It's about the industry. The user asking the provider to follow something because their regulation imposes that. is we're not talking about whether network regulators in individual countries are smarter or dumber or they're doing the right thing or whatever. It's simply that the banking regulations in Switzerland, in this case, or the industrial regulations in, as far as I can tell, in Germany, require that data doesn't leave the territory. And we're trying to satisfy this requirement for network users. So for this, and in terms of policy, something that we have started to think is about a service model.
Hey, Diego, you have 2 more people in the queue.
Oh,
Do you want to?
sorry, I didn't.
Yeah, go ahead, Edgar.
Yeah, so I think, there's been a fair amount of debate on this list about there's 2 sets of claims here being made. One is that there's some regulatory requirements, which may or may not be the case. I'd like to actually see them as people have asked for. And the other is some technical requirements. And I think the reason you're seeing pushback from Richard and also from me is the question is that we don't find the technical requirements very persuasive. So maybe they're regulatory requirements, but they might have to see what they actually are. And so if you're justifying this based on regulation, that's one thing. If you're justifying it based on technology, then regulation does not convince me that the technology arguments are right.
Well, when it comes to the pervasiveness, for sure, this is nothing that is not affecting all individual consumers or all the individual users of the network. But let me say this, they are impacting a number of relevant users of the network that normally are corporations. That's true. They are not physical persons. But the cases, and let me insist on the point that the regulations are in the what are supporting. We are not proposing to do something that addresses individual regulations in individual countries. We are trying to address the requirements of particular users, well, a number of users that are requesting this from their network providers.
So just to clarify, Diego, when you say users, it's the operators, not the
No.
end users.
It's the banks or the industries. Is what in terms of telcos we refer them as verticals, if you like. This request of not going through France in this case comes from the bank. It's not that the Swisscom or Sion or whoever is mandated.
Well, I'm just trying to make sure
Yeah.
so that those that are listening, they understand who the
Users are users of the networks, people that are paying for using their network services.
Okay.
I mean, we know there is pervasive monitoring of network traffic, right? It doesn't even have to be decrypted in many cases, right? Behavioral pattern analysis of traffic is also pervasive. And we also know that, if you are just an individual like us, you're not subject to being dedicatedly attacked. But many of those customers with their high value transaction going through foreign countries, they're also on the endpoints attacked, right? I mean, there are always things in the news. We had some example on the list where hosts are attacked, and key exfiltration is not a problem, right? So I'm not sure why we're keeping up this myth that the only thing the IETF needs to do is end-to-end encryption, right? That's perfect. We're doing that. Nobody is arguing it. This is not meant to replace any of that end-to-end encryption. This is just saying, as network operators, we also need to do a lot more.
Which is the other one?
Okay. Go ahead, Hank, and then is it Rutger? I'm gonna cut the queue there if I know
Okay.
how to.
Hi, this is Hank.
Is-
Yes, so I think there's 2 other details that might be of interest here. So in RATS itself, we have a ID called Trusted Path Routing, which is basically going in the same direction, right? So you have trusted paths and untrusted paths in the internet, in theory. So this here's a tighter scoped problem. And as an example for a tighter scope problem that is a real life thing is in the 3GPP, you have the 3 pillars like the radio, the WAN access, the system architecture, and the core network. And we tried network slicing here, for example, and that went nowhere. So this is basically at least less ambitious, I want to say, but more on the IETF side, capable, able or likely to succeed attempt to give the guarantees in the core network, I think, and that is just a useful item in tight scoped domains. And I think that's why all the scoping discussion has happened, because you have to understand in which scope is this useful. And again, 3GPP is one of good examples here that would really benefit.
Okay, that's it for the queue.
Looks really good.
Keep going.
Okay, so from this, we're trying to build a generalized concepts of what means to satisfy a certain set of policy requirements. We have come with this idea of the level of compliance, which is, well, I was working some time ago on identity, on digital identity, when the terms level of assurance is very much used. It's somehow derived from that, just to set the ground. This doesn't intend, the same way that the procedures don't intend to change anything around end-to-end encryption. This is nothing to do with identity, but that the idea is inspired on identity. So, and this is something that has been further applied when we started to work on network virtualization. It was further applied to show customers when we started moving certain functions to the cloud, etc., were really concerned about not being able to verify certain properties that typically were verified just of paths that were verified by following the cables. And we started to talk about this level of assurance inside virtualized networks. So the idea is we move it to level of compliance, because it's about compliance to a particular policy, a particular policy that is required, let me say, by the user of the network. And we have been working in several projects like this one that you have there that illustrate a way of assessing the privacy properties of particular paths. And we have use it as well in the how we could verify service level agreements that were imposed by a customer, and how we could provide this kind of verification. And this is something that is part of several pilot projects that we have run in our network. We believe that this, and this is why we're proposing to apply this in the service model, should be applicable in general in this particular case of the paths, and could be applicable in other cases, like, for example, auditing control planes and even telemetry and flows about data about the network itself. What is important as well is that, and let me insist on this, that we are supporting something that is important, is third-party auditing. What we are is generating data, generating evidence that can be verified by an independent party in support of the customer as well. And that third party can be whatever, whoever else, the user itself, someone that the user has hired for doing so, or I don't know, a regulatory body, though probably I should not talk about regulation anymore because it looks like a minefield. So for applying this, what we are trying to do is to measure or assessing the specific properties on a particular network path, whatever they are. Normally they are related to a security posture of any nature, about whether you're applying link encryption, you're applying certain security measures, or using particular security functions, typically to geolocation. It was the archetypal case that we were considering. You can consider about supported features, whether you use a particular extension or version of a particular protocol, patch levels, whatever. The idea is that when you are building the path, deciding how the path is, you can attest the path components using basically remote attestation components, and during the use of the path, you can perform attestation of the compliance. That means that you, during the use, can verify that the path is following the intended properties, passing through the elements that has been, the components that have been attested. And for that, what we're advocating is for techniques that has been discussed and proposed here in the IETF about proof of transit. And for this, these attestation results can be connected with a transparent repository that can be used for auditing, trust assessment, or whatever other purpose that you can that can be imagined. Again, transparent, so it can be used by third parties. Shall I stop?
Jafaz, so you're hitting path compliance is one of your requirements here. Proof of transit obviously can tell you that you've touched a box.
Sorry? Proof of transit?
Proof of transit can prove that you have touched a box. It is traffic is passed through a specific device. Proof of transit can't prove that the traffic has left the path and has gone a different way. From a regulatory and use case standpoint, how does that fit?
Again, we are from the regulatory standpoint. Frankly, I don't know exactly because we don't have, as far as I can tell, regulation of proof of transit. But let me say one thing: we are not trying to solve a regulatory problem. We are trying to solve a request from customers that have certain regulations. Let me insist on that. We're not trying to say the whatever is ordering, asking us to do something, and then we are trying to address it. Might be that some regulator may look at this and in the future and decide something. There are customers that have under the regulations of their business that requires the network to behave in a particular way. And what we are proposing here is to provide them with the tools for showing that they are regulating this. First. Second, the current proposal for, the current protocols for proof of transit prove that you have traversed a set of nodes, and even you can that you have traversed a set of nodes in a particular order. And it's true that you cannot show that you have not been, there was certainly being a mirror, etc. That's true. That's true. That's something you cannot, proof of transit is not, how to say it, is not perfect. There are some proposals ongoing about enhancing this to being able to provide, to prove that certain man-in-the-middle activity has been happening. This is one. Second, the combination of proof of transit plus attestation at least guarantees you that you have going through nodes that has been having been attested. You have an extra evidence that the path complies to the properties. On the list, people were complaining about, but that doesn't imply because physical control of the device, for sure. If someone has a physical control of the device, you are lost in that sense. We are assuming that there are certain properties that can enhance your assurance. You cannot have total assurance, that's for sure. We're not pretending that we can provide that.
Right, and so as my follow-up, and I'll give the floor. What I want to make sure here for the requirements is you're not actually saying that the requirement is path compliance. You have given use cases where when the traffic passes out of something that can be monitored, you can't prove that. So the only property that can be done here is proof of transit. Idea of path compliance, the only thing you can actually prove is proof of transit.
Let me say this, we are talking about path compliance to a particular policy at a certain level, because all these have costs in terms, not costs in terms of money, costs in terms of processing and delays and all the like, and then which is the level of compliance you want?
I buy your argument, but using the term path compliance becomes misleading in many contexts. That's why I'm suggesting pick something else.
We can, we would be more than happy if you have a better name to what I tried to avoid precisely originally started talking about assurance. But assurance has two things, two problems. One is that it has been used elsewhere, and we didn't want to associate this with identity or what NIST has been analyzing for authentication, etc. in the past. And second, to me, and maybe it's because from my mother language, assurance is much stronger than compliance. I'm not sure whether in English it's the same or it went in the opposite direction, but this is simply, we can find a better name for that.
So I'm just going to give you a time check. You have 8 minutes left, so I think you should just stick with this use case, okay, because, and I've locked the queue. You've got 4 more people on the queue.
Maybe can I just quickly report to Jeff, because I think there is a misunderstanding how much or how little the proof of transit with attestation can give, right? It can go far beyond just saying, oh, this is the following IP address of some unknown router that I don't know anything about it, but it can include exactly the attestation about the links that the traffic came into and the links that the traffic goes out to. And this attestation is simply, a cryptographic form of automating what customers and service providers are very often doing anyhow, trying to figure out what are the bloody links that my traffic goes through for failure analysis, for example, and also to understand, what probability there is that this physical link, like a dark fiber, does go through a specific geographic area or not. Right, so that's all part of the attestation data that can be given, and all this stuff is done today in many cases just manually on fax or email, as opposed to automated with attestation. Right, so take it.
Okay, on Rüdiger Volk. Well, okay, trying to shortly jump on that. I would wonder whether at least the concepts that you are discussing so far would be able to deal with a fiber plant from the telcos call it transport department, in defiance of OSI. That actually includes dynamic optical cross connects and all of that kind of stuff, and has links around all of Leck-Leman. Yeah, will you be able to figure out that, well, okay, the fibers that you are using and that are supposed to be just on the Swiss side are not diverting some of the lambdas once in a while somewhere else?
Let me say that's why we are not talking about assurance. We cannot. Rudiger, it's as everything in life, for sure. That there are potential attacks to a networking system.
Yeah. Actually, the very different point that I stood up for is, well, okay, following regulations required by customers or the law.
Sure.
The interesting thing is if you detect that actually regulations can be contradictory. Like, for a long time, we have this concept of oh goodness, I lost the word, lawful intercept. And the regulations for that, I'm sure in Spain are, as we had to comply with in Germany, are so that one, let me say, spy agency that has its hook into your router is allowed to do things there, and you as an operator and the router vendor have to take care that if another spy agency is looking at that router, there will be no transparency.
Sure, but
so kind of the question of assuring on the router that is compliant with legal lawful intercept is there. With that regulation, you are not allowed to show that your router exfiltrates data.
May I chime in a little bit? I think we are going out of scope because it's not about the nature of the regulation, it's about compliance of some requirements or claims, which can be regulation or other thing. I would add, NASR is not meant to protect completely, it's not a perfect solution. So question like, does NASR protect against wiretapping? The answer is clearly not. So maybe we can focus on more technical points, which makes sense. Thanks.
This is Zafar from Cisco. So I took notes when you were mentioning. You mentioned the need for policy enforcement, so that the point that you have in bullet number 1 can be satisfied. And that is supported by routing today. So we have means in traffic engineering, coloring links, affinities, that you can achieve these things, and that's your policy. The traffic goes in there. Okay. And then the other point you mentioned about the level of compliance, and that is also, you can associate level of compliance or these affinities in the network based on the level of compliance, and then you can build routing and traffic engineering part of it. And you actually mentioned it, these part have nothing to do with security, because you're going to secure your network orthogonal characteristics. The other thing that you mentioned, that you want to verify that the path is indeed the path that you intended, which is the proof of transit. I'd like to point out some work that is done in SFC working group. It's a working document, mature.
Yeah, we
and
are trying to be based on that.
Yeah, and it's based on a polynomial check, a cryptographic check. So I think you need to establish what is not there. Okay.
Let me say in one thing. First, when regulation, with compliance, we are talking about compliance to a particular policy that is requested by the user of the network. We are not talking, and the user may decide that that policy is based on whatever the requirements they have because of regulatory framework, or because of anything of the best practices in the industry, or if you like, because their management require them to go that way. We're talking about, I am using the network, I am the Swiss bank, and I tell you, I want the path you're going to use to behave like this, this, and this. And we provide the tools to showing that user that we are following that policy. And this is important, by the combination of remote attestation plus proof of transit. And the plan is to use as initial steps the remote attestation that RATS is developing, and using as an initial step the proof of transit that was precisely initially proposed and discussed in SFC. That's the idea.
Yeah.
Just to summarize the...
yeah, I think you need to establish what is not there, already covered by the routing or by the RATS working group. Okay.
Torles, you're in the queue next. Did you want... Okay.
One less.
Go ahead, Hank.
Okay, this is Hank, just real quick. Yeah, I think this will be the lawful intercept item. So trustworthiness is a characteristic that's checked with RATs. And this basically means as intended, and doing what it's supposed to do and nothing else. If that includes lawful intercept, that's a trustworthy node. I can't change that.
Exactly.
So as we're smashing these two things together, I think this is the best we can do. Yes, we can also have leakage on the links, but yeah, but again, this is a starting point. So
for network operators, lawful interception is like taxes. We would love not to have it, but
Sorry, the queue is closed.
I'm in the queue.
Oh, the queue has been closed. So.
I'm in queue. I'm the last one.
No, I had closed the queue.
Okay.
Okay.
Okay, no problem.
okay.
So
Maybe one quick question.
we're out of time. We're letting, so as the chairs, I'm monitoring the queue here. I think it's important for us to understand, as Luigi went through the agenda, it's important for us, both remote and here live, that you understand the problem statement. Diego only got through the first use case. And,
yeah.
But, which is why I'm saying, in the interest of time, I think it would be useful if you can just summarize.
3 minutes, yes.
No, 1 minute.
Okay.
But again, because we want to give Peter the chance to actually articulate in a different way, as opposed to just this particular use case, what the proponents of this BOF believe is the problem they're trying to solve with a proposed architecture. So again, I want to emphasize proposed. It's more to understand, is this a valid problem? Is it a problem that the IETF should address? And the proposed architecture, is that in scope for the IETF? So we need to get to that, which is why the use case is just one aspect. So you have 1 minute.
a promise. So there is a set of particular use cases that we have been considering. This is about, it's somehow connected to the thing was mentioning about slicing. Is guaranteeing that the path, the whole path from the device up to the cloud, passing through the edge, etc., follows certain properties. And there are another set of use cases that are regarding precisely different paths and how different paths can be assigned to traffic depending on the particular level of compliance that customers require for concrete application, like the case of training AI, storing data, or as you have here, about connecting to data centers or using an external computing path. So the idea, let me say, is about enforcing rules or rules where you are building the path, verifying and allowing third-party transparent verification that these rules are being enforced during the path usage. And finally, and this is a list of the policy drivers that we have identified about in terms of exposing data, whether they are personal or they are industry or trade secrets, etc. And that there is a list of the different regulations we have identified, and a few concerns we have detected in our users is about the regulations on data and digital sovereignty, about the fact that the data in the national industry remains in the national industry and is not exposed here or there, or the government. Customer requirements very much related to network virtualization and going to the cloud every services, and the scenarios in which you have mix of cloud and edge, you have intermediate nodes that play the whole thing. I will stop here. Let me insist, we are talking about building the path, relying on remote attestation, verifying the path, relying on remote attestation plus proof of transit. We want to make them evolve to join them, and this is totally 100% and is not intended to substitute by any means end-to-end encryption. That's
okay. No, that was 3. So Peter, sorry, you now have less time, but you're up next.
Thank you, chairs. Thank you, Diego.
Oh, did you give him the clicker?
Yep. Yeah. Okay. Works well. Thank you. I'm Peter, and I want to explain the problem statement and proposed architecture before everyone actually have a lot of questions. So I like to finish this part, and we can have all those discussions. Following Diego's use cases, I want to summarize and consolidate those into 2 problems. So the problem here in the yellow, in the left side, is the problem 1 is that the customer really cannot request or control like which geolocation it wants to go. Let's like with all those application layer security and end-to-end encryption, that's great, but that's it cannot fulfill, like, for example, it cannot, contain for certain traffic to be within certain geolocations. And also it cannot, help, the customers to choose like what kind of security requirements or security attributes of the network devices that he's, on the network deployment he's receiving. So like, for example, is this his network has integrity checked routers, that is the router using excuse me, is the routing using the latest crypto, is the router using the most recent security patch, and those are the things that I think humbly application layer security and end-to-end encryption cannot achieve. So right now, the current status quo is that the customer really have to implicitly trust their operators. Okay, they have to trust their traffic is safe, their traffic is compliant, their traffic is all the way. So it's just implicit trust. There's no way to verify, or there's no way to visualize all these security elements or security properties of the network he's receiving. And the operators are also having a headache because there's no means to provide assurance or proofs that he's delivering this kind of service. So the result is that with the traffic might go outside of a certain geolocation, or it might go to some vulnerable links or devices, those traffic could be captured. Like even though they encrypted, they are still subject to attacks like traffic pattern analysis, if you're not using post-quantum crypto, you're subject to capture now, decrypt later. And when you have a mailbox, there will be inspection. And very likely, if your endpoint is attacked and your key, even though it's post-quantum keys, and if these keys are compromised and your traffic is captured by some vulnerable devices, then your information will be leaked, sensitive information. So what's to be here? Like, of course, the customer wants to make sure that traffic is in a certain geolocation. Also, they want to make sure that, for example, their devices, their routers on their connectivity service have a certain integrity check, have passed certain integrity check, is secure booted, is also using the crypto he desires, and also he's using the security patch that patches all those vulnerabilities that he's concerned of. So the point I want to make here is that NASR is actually not to, the goal is not to boil the ocean. It's not a magic. It's not to, solve all the problem at once, but it's not a guarantee that a 0-day vulnerability cannot happen. It's only a way that if we discover a 0-day vulnerability or any kind, and if we have a security patch, NASR is here to make sure that you are assured to use this patch, and we are giving you proof to that. Clear enough? Cool. And here, so the solution here, like to be, is that we want the customers to be visible and can verify those security requirements of the network he's receiving. And the operators also are, also happy because they can assure this kind of a path behavior or forwarding behavior and the path security components or attributes, and provide verifiable proofs, and even automate this process using protocols. So I think that's the point. I think I saw there's one in the queue, but I want to finish this one first. Is that okay? Yeah. Okay. Yeah. Cool. Sorry, Eric. I just want to finish this one. So I think that was the gap that we want to fill. And this page actually answers the question that why we want to do it now, why we think now is a good time, and why IETF is a good venue. So like here, I want to emphasize, like, we build on attestation, heavily. We use attestation building blocks, we use attestation outputs, and we add something new to fulfill our goals. So here, I want to, ultimately, I think NASR will facilitate deployment of RATs, of remote attestation technology, in order to make the network more secure and more verifiable. So the point number one is that attestation technology is actually, remote attestation is actually ready in various vendors' core products. Okay, so it's ready, and if we do some additional extensions, then we develop on top of NASR, on top of RATs, would be feasible and tractable. So that's number one. And number two is that is about how attestation changed the security assumption or security model of our internet or network. So like before, when we don't have attestation, we don't have secure boot, then our security assumption of routers is that it can be compromised, it can be completely insecure, we cannot trust them like whatsoever. And under that assumption, we have end-to-end encryption. Don't get me wrong, that's great. We're going to use it. We're not going to replace it. And we have routing security, but there's a gap. There's a minor gap between routing security and forwarding security, because you can correctly propagate those routing informations, but you can't guarantee like those routers are correctly enforcing them, like making right forwarding decisions. So there are also great works like BGPsec that help you to protect the integrity of the propagated routing information. But now I think the point is that with attestation and secure boot, we can make sure like these the forwarding behaviors or network behaviors of these devices could be enhanced, right? So this could somehow close the gap between the routing security versus forwarding security. So the last one is that attestation technology actually abstracts a router or a network element into a set of claims. So in this case, it's very nice to see them there as a list of claims, and we can have security distinction. We can easily pick from them. We can easily visualize. We can easily verify, and this is why we think this is. This actually answers the question like, what is NASR, right? So when we have the security distinction, we can choose the preferred device with preferred security requirements. We can set up this path that you want, the customers want, and we can verify forwarding. So before jumping into the architecture, I think there's several queue.
Yeah. Eric, you're in the queue?
Hello. Yes, I've been following the NASR work with interest. I'm glad you mentioned the work in rats. I do think that there's the RFC 9684, which is showing the attestation work that's already going on in rats. So I do think that there is a lot of work that's relevant in other working groups that can be integrated into this problem. My question really comes down to the question of where does this type of work fit? Considering that we already have stuff in rats, and you're mentioning it, and we've already talked about, Hank also talked about the trusted path routing work, which is derivative of rats. Why NASR now, considering there's already a home for routing work over in the other work groups, and we actually have RFCs coming out there?
Thank you, Eric. So actually, in the next slide, the architecture, we have little boxes showing what belongs to rats and what are the new things that we want to develop here. But I want to answer your question is that TPR, like in here in NASR, actually, when placed in the security area, we don't, we mostly focus on the verification of a path and their attributes. So we have a management plane, extensions or netconf YARN models that try to collect those information and aggregate them. And when in the forwarding plane, when we do proof of transit, we want to extend proof of transit data field. I think that's something maybe out of RAT's scope, and something is actually new. I don't know if that answers your question.
Not quite, because the proof of transit still is only temporary. I mean, you're not going to really know where it's going.
Let me just say, Michael Richardson, that 9684 is probably a core and important part of this work. And so it's not that we're replacing it, we really want to leverage it. And I think your next slide says that.
Yeah. Next, please.
Go ahead.
Okay. So Wu Jiangcheng from China Mobile. So from operators' point of view, I think it's useful. But I have one question about, you mentioned the pass, right? And what's the meaning of the pass here? Is that a TCP session or SRv6 VPN tunnel, or it's such as the physic link combined with such as a fiber and the physical node? What's the meaning of the path here?
So I think there's a document in PNRG that actually defines what path is. Path consists of nodes, which are network elements. For example, it could be hard, real routers. It could be virtual routers. It could be services. So in here, I want to say you can say the most common use case could be like a SRv6 use case, like with real routers. It also could be like there will be service function chaining, like there will be virtual functions inside of it, like anti-DDoS. So like if a customer wants to make sure the connectivity has anti-DDoS service, it called the element here is in the path. It could also be like a virtual function.
Yeah, so the physical path and the logic path, the database is totally different. It's huge. So yeah, maybe you should consider that.
Mankamna, Cisco Systems. So one of the question is what we are understanding here. One is the trustworthiness of the network, and the other thing what you're trying to achieve is traffic engineering. So these two work already exist in two different places.
Sorry, can you repeat the second?
Traffic engineering. So you are looking for trustworthiness and traffic engineering. So all of that already exists today. We do traffic engineering. We have trusted path network, and I think Diego himself is author of other draft in RATS. So what is new coming in this NASR work?
Do you say traffic engineering? That's not really, that's not, sorry.
If
So, of course, we need traffic engineering, but the customer needs to know that the traffic was engineered the way the customer asked for it. That's what we're asking for. Okay. So how do we translate that? Well, that's one of the open things. And I think your next slide has that gap, right? There. Yeah. So there's bits and pieces here. The customer says, okay, I asked you to engineer my traffic in a particular way. Show me that you did it, right? Like one of the questions I asked, is I asked for two redundant paths. Show me that actually they're actually separate, right? That none of them go through the same sewer, right, at the same place, which I have an existence of someone stealing fiber and breaking lots of networks, and all the redundant paths went through the same bundle. That was bad, but no one could tell.
Zafar?
Yes. So can you go back to the slide where you have the YNAS?
No.
Slide back.
Oh, he's got the clicker.
Yeah, this one. Yeah. So I think the problem that I have that you are asserting on problems, which is as is, and you're asserting solution does not exist. And that is not true. In routing, we have solutions for geolocations, like Mankauna mentioned about traffic engineering, affinities, passing things. And in routing also, like we have construct about diversity, how can you place things to make sure they're diverse from each other and all. Then the only thing that is come down to, so you have all the construct you need to steer traffic, the policy aspects, you have those constructs from routing. Then I think there's only thing is boiling down to is you're saying proof of transit, and proof of non-transit is outside the scope for you. So the proof of transit work is also being done in routing in SFC. So I think what you need to establish how you go from yellow to green, and you're showing a lot of gaps that doesn't exist, and there are work done in IETF to address those gaps. So.
Well, certainly this is an overlapping place between the routing and security, but when you're having this kind of extension, I'll say it's more a security problem.
I mean, it's more of a coordination between the routing area and the security area, and we have means to coordinate that. So this should be done that way, like the YETF does, the security and routing coordination.
So I think the discussion here is about whether or not the problem exists, and then it's like where should we do it? So I think this currently we're gonna leave this to the discussion later.
Okay, I think yeah, this is where I'm coming. The problem doesn't exist.
Thanks.
Thank you. Can I speak? Aram Welling from Oxford Information Labs. So, can you need to speak louder?
Yeah.
No problem. I usually don't have trouble with them just getting started. So, okay. So, this is. I think what we're forgetting is some important elements here. What we're suggesting here is fragmenting the internet. I mean, just fragmenting. I'm sorry, when you start using terms like preferred, okay, preferred pathways, we forgot one major element. It's the human element, okay? Who is doing the determination and eventually taking capture of the forwarding? Who are these people behind this curtain, okay? And what can they use with that power? We have to take that into consideration. Everything looks rosy and, can solve the problem, but there's people behind there, okay? Excuse me, I'm talking right now, if you don't mind. So I think we have to take into consideration the security aspects of what we're suggesting here itself. Okay? When you start talking about preferred pathways and what is going on with that, who are we excluding? Who are we including? Who are these people behind the curtain who are now getting preferential treatment for being able to provide these services, and what are they doing with it? And how will that lead to capture in the future? I think you have to be careful of those type of aspects as well, instead of just looking at, oh yeah, you know, we can provide this pathway that's assured. Who's providing this pathway?
May I just a quick point on one thing. This is not about excluding or including. That's the wrong terminology to use. It's just about a path that is compliant to that set of claim and requirements. Now, the path itself is how you build the path is out of the scope of the working group. This operator, this routing, okay, what we want to do is here is just if this path is available, is compliant with what I need. That's all. And then have a mean to verify on the other end that the packets went through a set of nodes that are compliant with my requirements. Does this seal everything? There is no leakage, no everything, no malicious attacker? Absolutely not. Absolutely not. But we are kind of providing an attestation that there is a certain set of nodes that has a sufficient level of we can trust on the being compliant with the set of requirements we have. So it's not about excluding, including anything.
I have an answer to that. So all these use cases are not internet use cases, are limited domain use cases. I want to make that very, very clear. It is within a single administrative domain of a single operator, and it does not affect internet. So that's number one answer to that. And number two answer to that, there's no like preferred from any legal or regulation perspective. There's no like preferred, we want to exclude anyone. We want to insist on neutrality and fairness principle that only our customers would like to, if they have some security preferences, this is just a security enhanced services. There's nothing to do with, we want to extend this to kind of policy. No, this is a hard no. So that's number two question to that. And number three, if you don't like, this process, you can just skip whatever I'm trying to presenting here in the architecture. You don't have to choose, okay? You can just use this technology on your existing deployments, and you can see what are the security postures on them, what are the security attributes of them. If the traffic is going well on them, that's good. Does that answer your question?
Yes, thank you for helping me understand the boundaries, because I wasn't sure from the earlier presentation where the boundaries were, but I think I understand now, so that's fine.
Thank you for clarifying, actually.
No, but I needed to know, because you can see how this could expand into something that could be problematic, so thank you.
Okay, so I'm going to do a time check and process check. So we had allocated time for Q&A, since you're the main one speaking to the problem statement and leading to the proposal. I'm going to let this run for another 10, 15 minutes. Okay. So, because there's still 5 people in the queue, and Cullen is next.
Cullen Jakes. So I'm not arguing anything. I'm not making a statement here to make a statement or argue things one way, but I have a sort of comment about a part I'm confused on the requirements and hoping to get a bit of clarification. And it seems to go back and forth other ways. I'm going to have a hard time phrasing this, but it's about the requirements for the nodes that don't do this, or is the requirement to be able to detect, I mean, if I had, a router connected to a switch connected to the routers, and both the routers are doing attestations fine, but the switch doesn't do anything, is the requirement to be able to detect that and know that this traffic went through a path that didn't, that had some elements that we don't have any assertions about? Or because some of the time when I hear the requirements, it sounds like that's a requirement. And other times it sounds like it's not a requirement. And it seems pretty critical for this path validation thing. I mean, if we want to, is it a requirement to guarantee that all everybody on the path supported whatever property I asked for or not? That's the requirement I'm confused on. Can you talk about that one a little bit?
Yeah, it's actually This really depends on like what layer of devices actually support remote attestation and what layer of protocol we're extending. So right now, like we have routers that are supporting remote attestation, and we have routers that can, read those extensions and do things. But right now, like we're, looking, we're seeing switches in the links as layer 2, like just a link. And I think it's another problem when if we think switches can support remote attestation, yeah, that we can extend it on the layer 2 things. So there's a technology that it's really a problem of extending to what protocol.
But the question is the requirement to be able to detect if there's any nodes that do not support it, or is the requirement only to know about what the node, only a positive attestation about, we know we went through these nodes and they all did X. That's one requirement. A different requirement would be, we know it did not go through any nodes that did not do X. Okay, those are two very different requirements, and I am not understanding which one of those two is the requirement for this working group.
So absolutely, we're not proving what we are not going through. So this is like a myth. So this is like you don't know. So we can only be sure, like this is how we establish RATs and remote attestation and trust and everything, because we have a trust root. And then we build things on top of it, like layer by layer. So what we can do only is to prove that we have this root of trust, and we have this device that is have integrity check. And what we can do further is link, like what kind of ingress or egress interface is coming from and going out of, and what link protection we are having on that. And this is the best we can do in the layer 3.
That's great. I think that really clarifies one of my confusion points. Thank you.
Hi, this is Hank, really quick. This is a blast from the past dialogue-wise, but why not doing this all in RATs? RATs seems to be relatively saturated with work. We had this interesting feedback yesterday. I'm not entirely sure how much we can squeeze in there still, but this seems to be too much. So I think that is just a logistical reason. Also, that we, as we had heard, SFC roots, or the initial ideas from there are combined here with other things, and we have some other gaps. So yeah, if we put that in RATs, it would explode.
Next, please.
Thiru Nokia. I have two comments on this one, right? Proof of transit requires transit to be proved for every packet. And that was one challenges that we faced in service function chaining, right? I mean, the cost of adding proof of transit for every packet, right? That's the reason the proof of transit document became an experimental one, right? And then it only proves that the packet went through certain number of network functions, but it doesn't prove that it went through some network functions which were not designated to look into the packet, right? So you're not solving the problem that if the traffic traverses certain nodes which are non-compliant, right? You don't have proof of that. Proof of transit doesn't help you that. The other question is, I saw two arguments. One is basically referring to regulatory compliance, and the other one with regard to security, right? I mean, even the work happening in RATs is susceptible to PQC threats. It's using signatures. So using traditional signatures, yeah, algorithm signatures, it's susceptible to threats. So any cryptographic operations are susceptible to threats. Even RATs is susceptible. So are we doing this for regulatory, or are we doing it for security reasons? I think that requirement should be clearly articulated.
Okay, I got your question. Like the first one is how performance is impact, right? So like proof of transit, the simplest proof of transit is signature. Like signature, like another signature on top of it. So another signature on top of it. But that's not viable. That's not feasible. So the most feasible proof of transit here is iterative hash. So this is where we kind of put here. So iterative hash, like think of like a TCG measured boot. They have this kind of hash from the root of trust and to the firmware, to the hardware, to the firmware, and they had this hash iterates every level that goes up. So and all the up, you have a good hash. That means every layer is integrity checked. So this is how we're gonna do it on NICs, on devices. So if we want to use iterative hash, and then we have, if we go through the node A, the hash again, and the node B, the hash again with his information proving his process, this path, and it's coming also the ingress and the egress interface the packet is coming from. So you said every packet, yes, it's on an IP header, and the hash is not very performance impacting. We kind of did some analysis on that, and the performance for a very high throughput, that's not a huge impact to that. I think we have time check.
No, actually, I was just quickly to add, I did an implementation of proof of transit on SRv6. To be honest, the performance are very, very good. So the proof of transit operation, the cost is peanuts. I presented in spring. Yeah, we can talk later on offline on the performance.
Yeah, thanks. Next one, please.
Jean.
Yeah, Jean-François. I admit to still have a little bit of difficulty to frame exactly the environment where you are envisioning this to be implemented. I initially thought that this was could be something global for the internet, but then you just made a comment that it would be for a specific domain. The question that I'm asking in that case, so do I have it? Do I understand that properly? That it's just for a specific operator or network?
I want to make it clear.
Trying to understand that.
I get your point. So if it's a very close private network, then there's no meaning to it. There's like the meaning will be very minimal. And if it's in very big internet, public internet, it's not doable. So it's something in between, right? It's something like a limited domain, but still like it's kind of big, because like China Mobile here runs a metro network that actually kind of covers a city. It's kind of a, it's big enough. And also sometimes they're like across provinces, across states. And these are some like a middle-sized network that could use this kind of technology and make sure it does not go to other states or another areas.
Yeah, so I do see the benefits in one side, and I do see the risks in the other side. So my problem is right now I'm not 100% sure where to balance myself in that particular line. So if you're going to be looking at something that is middle size, nothing really stops those who are looking into the bigger size to also adopt it. And my concern is not so much the technology itself, but who in the stack is going to be able to make the determination as to whether you want to use this technology or not. Is it going to be the operator? Is it going to be the final user? Because there might be an interesting case scenario in which I want to make sure that my traffic doesn't go through specific paths because I don't trust them. But that's my decision as a final user. If you're telling me that it's going to be only implemented at the operator level, then you have a problem, because maybe the traffic is going places that I don't want. So how do you envision this to be implemented, and who do you think would have control as to how this is going to be used?
I get your point. And I think I have an excellent diagram here that explains your question. So in here, like you see, you have this relying party. This is actually a customer, like an enterprise. If you are, having connectivity, mostly to B use cases, to business, and then you have those kind of requirements that solely comes from you. Is that clear? And then it's passed down to the operator. And here you can see this is the orchestrator. It actually runs by a ISP or operator. So this requirement is passing. So the very important point I want to make is that there's no any kind of legal or policy that we want to enforce. It's just all your decisions on objective security properties.
Yeah, all I'm saying that if we're going that road, we should also try to encourage implementers to provide the interface for the final user to be able to use these kind of things, because otherwise only the operators will. You're adding a layer of complexity for the final user as to how to do those determinations, and making those decisions not necessarily easy to translate.
I get it. So before you have contracts, right? But here you can see like the number one little blue box here is a security property request, and we picture that as a service model draft. We welcome you to join and discuss about it.
Yeah, thanks.
And I think I have cleared the queue, and coming to the architecture, I think I covered a lot of them with all these discussions. So you can see this is basically a 3-step or 2-step process. So the 3-step is to choose, set up, and verify. So you can choose whatever preferred security properties, sorry, I forgot the name, is presented, is purely from customers and passed down to the orchestrator. The orchestrator will choose from them. And then the most two important steps as pictured here in the left and in the right. So in the left is before use, and the right is after use. Sorry, during use, if if that's clear enough. So the left is like a setup process, and the right is a verify process. It's very similar to the measured boot or secure boot in the TCG, right? So you have the security baseline, whenever you're manufactured or configured the first time, and then you have the security baseline for every layer, and you have a hash to that, and that is security baseline, right? So the left side that you're looking at is a process of establishing this baseline. Okay, so you have this security requirements coming off from the customers, and the operators will, on behalf, choosing or actually have orchestrated a path, but that's actually out of scope of here because we're placed in the security area. Consider that we have received a sales routing or any kind of path that's from outside, and then this path, the elements, the nodes on this path will be collected, the properties will be collected through, for example, netconf_young. And then it's collected and aggregated. You can see those little arrows going up, pointing up, and then it's aggregated and verified and evaluated. And then there is an initial like a proof or report that you requested this kind of network, and this is what we prepare for you. Okay, and this is a proof. So this is the stage 1. Okay, and then you have proof of transit baselines. Okay, you have this comparison, because in measured boot you have this hash that is, if your hash actually computed is equal to this hash, then you're right. If something is wrong, is tempered, then it doesn't match, right? So in the second proof of transit, during the actual use, what we do is that we extend a proof of transit data field on an IP header. And then every node that processes this packet will compute and replace this hash function that includes his information, like I'm router A. I have these security features, and this comes from interface 1 and goes out from interface B. And then those, hash is constant length. It's just whatever you want to put inside of it. Okay, and then this hash will iterate and all the way to the last node, and there will be like a final hash to it, and then it can compare to the baseline we established in the first stage, and we can make sure, number one, this traffic actually went through this path hop by hop correctly as we expected, and number two, those hops are the one that we established the security baselines. This path and these hops actually have those security requirements that we have, like that, thanks to the first step. Does that make sense? This is basically attestation plus proof of transit solution. And in here, the little green and the blue boxes here, actually the existing works in RATS and new works we propose in NASR. So in the green we have step 3, there's actually TPM Chara, and in the 5, you have appraisal. Everything is defined in RATS working group. But here, like the blue box and like step 1, there will be a service model, the automated service model, and then there will be the aggregation, draft that deals with aggregation. And for example, what we are, because we have a lot of nodes and elements. How do we decide they collectively present? Like, do we choose the minimum of it? Do we choose the average of it? Do we choose, like, those are the things that when you do aggregation and everything, your measurement is something you have to consider. And then all the right part is, of course, what we want to do here. So,
okay,
yeah.
Peter, your time, I'm allowing 3 more people in the queue, and then I need to close you out because Luigi wants to go through the charter.
Yep, the slides are done. It's just, questions.
Okay, go ahead, Edgar.
Yeah, so I actually got in queue quite a bit earlier when you were talking at the beginning part of this. So I'm trying to wrap my head around it. So there's some attestation that covers the binary and the configuration files, the entire configuration of the router. And I, as the relying party, am supposed to inspect that and determine whether or not there's an acceptable configuration. That's the situation. So I have to study every single configuration flag to determine which configuration flags are valid and which combinations. And this requires like effectively a complete read of every configuration file and the whole manual to determine whether everything is okay or not, right?
Do you mean every configuration file for every network node in a topology?
What I mean is what I'm receiving is an attestation that signs the binary and the configuration of the router, right? And then I need to write a program as the relying party, which evaluates that information and determines whether this is a cromulent configuration. And that means the person running that program has to inspect like the entire configuration, the entire manual of the router, and determine which configuration flags are permissible and which combinations. And as DKG pointed out in chat, some of them are like unknowable. Like, what if it says, I listen to BGP for routing? Is that okay or not okay? Because it doesn't tell you anything how the thing's going to do. And so my concern here is that the situation where attestation works moderately well are ones where the actual scope of things that the system under measurement does is narrow, like plays video. But when it's like I'm a general purpose computer with a giant configuration file, I don't understand how I'm supposed to evaluate that and determine whether it's okay or not.
Is that a question or comment? Sorry.
Well, I'm asking. It started as a question: is how do you expect this to work?
He's saying there's a lot of network nodes of which they're going to have their own configuration, and then your orchestrator in the architecture, how are they supposed to validate the thousands, or because you're going to have lots. So it's a question.
Well, I feel like it's more like implementation question that is not really like, if you look at how do we abstract each network element, is just basically a set of claims, and how do you find from all these configurations is actually, I feel like it's more like implementation problem, not a is this problem a problem.
Well, I guess, but I mean, like I'm trying to get you to persuade me it's going to work. And like what you're saying is I'm going to look at this and do something, but that doesn't really persuade me. So I kind of get you to persuade me it's going to work. And like, my job is to write a program that will evaluate this data and determine it's good. How do I write that program? It's not a matter of checking the hashes. It's a matter of inspecting the thing that I've got the source. I've got like the binary and I've got the configuration file. Is that good or not? So I got to answer yes or no. How do I do that?
Yeah. I think, well, can I leave this to the discussion later?
Sure.
We have the time check already. Sorry.
Okay, we've got to make it quick.
Yeah, it's really quick. Zafar, you made an assertion. The proof of transit on every packet is not expensive. Maybe you have a very cool way, but I can tell you from an implementation experience for all of these technologies that do per packet, O&M on anything, these operations are expensive. But let's assume you have a very good solution to solve, which is good. The question is that why you need a working group. There is work in SFC. You can contribute to that work and improve it. It's a working group document, and people are welcome to do that. Why do you need for just these things? Maybe you have cool idea, maybe you don't, but that one has to be established. And then why this work cannot be happen in existing working group with RATs and routing area helping you.
So I guess this is how the perspective you're looking at this working group, proposed working group. Okay, so if you're looking at specific works, definitely it can be scattered all over IETF. But that's from the perspective of single works. But here, if you're looking at it in a more high level, like what we are actually trying to achieve here is that we want a framework of networks that the customers can visualize and verify and know what are the security requirements, what are the security status quo of the network he's receiving. So what this is like more like a framework, innovation here. So I think the point is, if we have more advanced things like QKD and post-quantum crypto, like this is a framework that can help you assure delivery and verified delivery. So this is not from the perspective of the vision of what we are trying to do here. It's just we're trying to have this kind of framework, right? And then we have different pieces of how to achieve those. I think it really comes from the use cases,
right? Because the use case demands us to, know and verify and visualize and verify those attributes, right? It comes from the use case. So I think this is why we need a framework that, really targets at the specific use case and do only minimum required work for extra.
But there's
Okay, we have to be really quick. Sorry, Richard. The queue is closed. You can ask it when Luigi goes through the charter.
Okay, Rüdiger Volk again. Let me first kind of confirm Eccles' question. In my opinion, well, okay, I have been responsible for getting lots of router configurations deployed and hopefully correct for a quarter of a century in a serious network. Actually figuring out well, okay, the nodes that you are showing at the bottom of everything have typically very complex configurations. And they have dynamic routing state and dynamic interface state, because interfaces may go away. And making attestations about correctness and certain things there looks like extremely challenging. For Eckel, well, okay, you don't program this. You actually need to have logic assertions about your systems and then work in logic. But Peter, the question I have for you, the way you have been talking is the path, singular. And not even, well, okay, talking about path forward and backward. And in real networks and with most real customers, they usually are not only regulatory requirements, but also requirements of service availability, which mean that typically you cannot provision a single link and be done, but have a network where actually a lot of different paths may be required to be used. And well, okay, that seems at least to imply another challenge on scaling if you actually go beyond the singular path. Yeah.
Okay.
So
thank you, Rüdiger. I think those are wonderful questions. And I think you kind of actually gave two reasons why this should be a working group. Because like attesting to a device and therefore, affect the network behavior is hard. And also like how do we do like tolerance or fault, like rerouting or everything? It's actually very challenging, but meaningful. So I think this really becomes like a problem of scope, like how ambitious we are. How do we want to do, of course, proof of transit can do like multipass or anything. It can, of course, and because the paths only take one way, right? And then you can have all this kind of traffic engineering, we have multipasses, and then the point is those are challenges that we have to decide if this working group, like the first stage, can or want to.
Is it going to be quick, Rega? Because
yes.
Okay.
So let's go back to the 30 years ago telco world of fixed circuits.
Not really. Not
okay.
really.
So I mean, it does beg the question of feasibility versus scope, right? So to that point, I'm seeing lots of feedback, lots of comments on the chat. I appreciate everybody coming in and bringing comments, which is why we let the Q&A go during the presentations. Hearing all of this, I'm seeing the room kind of still trying to understand sort of validation of requirements, but scope. And so we actually worked on a proposed charter that speaks to how we could narrow the scope into something that may be pragmatic. So Luigi is going to go over that before I can go ahead and answer the questions. Okay?
Thanks, Peter.
You want to stand? Want to?
I can. Let me share the slides. There we go. Okay. This is the first one. Yeah, so actually in the slides, there were a few slides that present how we tackle the feedback we received last time and during the BOF, and the IAB sent us feedback, and the mailing list, etc., etc. Slides are available on the data tracker. Please have a look for that part, since we don't have that much time right now. So I will try to cover the proposed charter, which we worked out through the various interim meetings that we had. So at this point in time, I hope that it's kind of clear that there are communication entities, there are available paths, there is end-to-end encryption that goes a long way to protect the traffic, okay? But there is an increased demand and some use cases that ask for slightly more. So the more is enabling visibility of the entities, security posture, a necessity. So this means that communication entities need to have a visibility on the path. Doesn't mean it's the end user. Okay, this is a service an ISP is selling. So the customers of this service may want to see something inside, okay? Some visibility on what is happening and what is going on through what is the kind of node that we have and what is the path, okay? Yeah, this part covers a little bit the possible threats. I may agree there was this thread discussion in the mailing list started by Eric Rescorla and Christian Wittema, etc., etc. So maybe we didn't clarify that much the fact that there is already end-to-end encryption that goes a long way. We are adding something which try to make existing threat less likely to happen. But then, as I said before, I mean, wiretapping exists. NASR can do anything about that, and end-to-end encryption cannot do anything to that. So you can store and decrypt later. I mean, okay. So what we want to do is to provide an added service that goes beyond the just encryption, end-to-end encryption, okay? So to provide this visibility on the security posture on the underlying network elements, okay? So how you provide this visibility is the attestation part, okay? The attestation technology is sufficiently mature to be used, okay? RATS is a little bit busy and the charter doesn't fulfill really what we want to do here, okay? So definitely we will use RATS as a building block, so to prove some claim set, I would say, on the nodes that are along the path, okay? But in RATS, there is the proof of transit part that is completely out of scope of the RATS working group as of today. Okay. So the main goal is pretty simple. There is a service where I can ask if a certain path satisfies a set of claims, okay? And if this path is compliant with my claims, that I can use it, and there is also a way to prove that my packets goes through this set of nodes. Does this solve every possible attack, every possible threat? No, but it's something that is a requirement in some use cases and is something that improves the security and trustworthiness of what we do. There is a question about the scope. So we don't go large scale deployments, inter-domain, et cetera. This is a specific service. The working group to be will focus on an initial single domain the deployment, and then how to transfer this attestation and the proof of transit to other domains with which we have a business relationship. But is not for large-scale deployment. So just want to go quickly, more crisply over what is in scope and what is not in scope. So in scope is to provide this architecture. Peter gave a glimpse of what we think would solve the problem. The procedures and network path attestation, this interface between different domains that have a business relationship, the proof of transit, okay. We don't want to do any path computation according to any set of claims. The routing part is out of scope, okay. Operational security incident remediation and stuff like that, out of scope. The methods on how to assess the integrity of trust level, this is more into Rats technology. What we want to do is define a way to express the claims, okay, and receive the attestation back, so that we can make a choice on which path to choose. No public internet deployment. This is a specific service. It's not even I deploy this in my domain for all possible communication. Okay. If I'm an operator, it's not that I propose VPN service and I do only VPNs everywhere, right? So this is a specific server. There's a big question about proof of non-transit, which is understandable. This boils down to the question, can we solve everything? No. Okay. Can we prove the non-transit? Impossible. I mean, this is Heisenberg principle if we go to quantum mechanics. But the point is, if we cannot observe, we cannot prove the fact that. So yes, there are threats. We try to be reasonable. However, in the slides that I didn't show about the feedback, one of the things we added in the what we want to work on is the threat model. We certainly need to clarify what we can protect, what is the, let's say, the added value compared to end-to-end encryption, okay? And what are the limitations? Because there are limitations, okay? So that who is the buyer of the service can make a reasonable choice whether or not to pay the service, okay? So this is the initial list of possible key deliverables. So use cases and problem statement, we need to clarify, but we need to document this in a clear way. In this document, we want also to add the threat analysis. So really document what is the added value of NASR compared to end-to-end encryptions. What are the limitations? Not a perfect solution, magic solution for everything, okay? There is the architectural part. Peter gave a glimpse so that we have the general architecture of what we want to do. There is the service model, okay? Because as I said, this is a service. We need to define what are the standard interface between the operators and customers, etc., etc. Okay, we added a deliverable of the attestation claim set. So how we can describe what we want along the path and whether or not the path satisfies our claims. Okay, again, this roots in the RATS work, but extend it on a path semantic. Okay, and obviously at the end there is this proof of transit. What we want to make sure that we want to verify that the packets go at least through a certain set of nodes, okay, for which we have an attestation that proves that that node fulfills our claims, okay? And there are various ways to do it. I'm sure we will work it out. That's not really the critical part. Okay, we will work especially hand in hand with RATS, okay, and other working groups as need come. We have an overlap with Panergy, it's a research group, but it's path-aware networking. That's exactly why, in a certain way, what we do, in the sense that we want a visibility of what happens in the middle, okay? Spring is because if we want to follow a path, Service X could be one possibility, okay? But we will not fix on any specific technology on that side, but could be a connection, okay?
You might want to, yeah, because you've got a queue.
Happy to answer any question because I'm through.
The queue will have to run quick, by the way, because I want to save the last. No worries, Richard, you're next.
Richard.
You need the last 10 minutes for me to ask the consensus questions.
Yeah, so I actually wanted to ask a clarification question. So Peter, if I could have your attention for a moment. Last presenter, where did he go?
Peter, actually the question is for
Peter,
you,
yeah.
apparently.
So Ecker glided past a question that I had. So Ecker was asking, how do you interpret all of this information? What I wanted to confirm is that for this system to work, the attestation needs to include the full image information and configuration of every router in the path. Okay, so hey, yeah.
Yeah, so this is not how remote attestation in privacy or confidential realms works. So you need the attestation.
Louder, Hank.
Right?
Louder.
Louder, okay. This is now how remote attestation in confidential or privacy-prone environment works. You need an attestation result you can trust from the verifier that you trust. You do not have to expose all that. That will be a huge problem. Yeah. So that is not how RATS works.
But right, so the attestation is going to state certain properties about the thing being attested, right? That's what an attestation is.
I assume you mean the evidence originating from the target of evaluation, the tester. If that's the attestation you're talking about, that always includes, of course, hash values about the things you measure. You do not have to convey the thing. You have to just to confirm that the thing is the thing that's supposed to be there and compress that.
Okay, so, yeah, sure. Okay. Yes, so technically, you know, in the attestation statement, you might convey a hash value, but in order to achieve the objective of this system of verifying properties of the network, I need to know the hashed values so that I can interpret the state of the router and make predictions about how the router is going to behave, correct?
Right.
Okay, so the question I'd love to hear feedback from operators on is, are you comfortable exposing information about the configurations of your routers and what software they're running to everyone who is a relying party of this system? Would love to hear feedback.
Hank just state that this is not the case. You are not sharing information.
No, Hank stated that the attestation can just convey a hash, cryptographically correct. But Peter confirmed that in order to achieve the objectives of this working group, the information needs to be revealed to the relying party so that the relying party can interpret the behavior of the network.
It's the hash value.
In between the relying party and the tester that is a target of evaluation, there is a trusted third party called the verifier that does that job for you. You have to put trust in that appraisal burden carrying thing.
Well,
in general, I would say this is a RATS question. Maybe it's a RATS question. Maybe in that working group, but was yesterday.
If I may,
this is a clarification about what information
Right.
needs to be exposed to make this working group make sense.
if I could answer this, right? So from the RATS perspective and the attestation verification, it's not that you're keeping the whole configuration or raw value, Richard. you're keeping that hash. So you have a golden set, which isn't necessarily disclosing all of the information. It could be a hash.
And configurations are never changing.
Okay, thanks. Just wanted to get that clarified. Second thing I wanted to say is that I'm a bit confused here because we had the use case presented about attesting this France-Switzerland situation, which addressing that use case requires attesting everything on the path. And at the same time, when Colin asked, Peter said that we weren't going to aspire to attest everything on the path and prove the non-existence of non-conforming things along the path. I'm sorry.
You need to get on the mic.
Yeah.
NCR.
Do you want to disagree here?
We have to attest all the positive things on the past. We're not going to attest that there's not anything else in the past because that's impossible.
Right.
Okay?
Okay, great. But if you don't do that second thing, you don't meet the use case of keeping traffic inside of Switzerland because one of those things that's in the middle that's not attesting may have violated your security properties.
Assuming that the traffic got to those other things.
But
right?
you just said you're not going to approve.
No, but so what I'm saying is what you're saying is you and I can't prove that no one is listening to our conversation, right?
But that was the use case.
But hang on, you and I, we're having a private conversation. You and I can't prove that no one is listening to us. Is that true?
Where are you going with this?
Well, so the point is that we could be in a Faraday cage. We could attest to the fact that we're in a Faraday cage. We could attest to the fact that we both search each other for hidden microphones. Having done that, we now have an assurance that I'm not leaking the information and you're not leaking the information. So at that point, if someone was listening to us, it must be somehow beyond our knowledge, right?
But to put this back in IP terms, I think what you're saying is like you can say that your router A, you sent the information to me, router B.
Yep.
We're both attesting, but the scenario Colin raised was that there's some switch in the middle. They could be doing something, and there's fibers in the middle.
And you know about MACsec, right? I attested that we're doing MACsec, and you agreed that we're doing MACsec, and we may even attest it to some shared or hash of some secret that we negotiated as part of our key negotiation, that we are also doing that, right? So do you agree that we could say that I think I'm only talking to you, and you would say that you're only talking to me? And so if there's someone else in between, it's because they've defeated all of our cryptographic stuff, right?
Okay,
right?
Fair enough. Thank you.
Okay.
All right. Nicola?
Hi, this is Nicola Rustignoli from Scion Association. I wanted to chime in as there was some discussion also on the chat about Scion and NASR. So first of all, regarding the problem and the use case, we do think there is a problem and a use case. You mentioned the Swiss banks, and indeed the Swiss banks are today using Scion for the interbanking network. But here the approach that Scion takes is a little bit different because it kind of first of all, it is interdomain and it does secure path awareness. It allows the users to select which autonomous systems this traffic should go through, which so far was something that was good enough for this banking use case. So regarding adding proof of transit, this is something that we discussed this before. It was evaluated as an experimental extension to Scion, but it is not yet part of the production network because, as I mentioned, the general only interdomain part is good enough. And when it comes to the scope of the work, then I think for us it would be valuable if what you do is somehow intradomain. And then if you look at interdomain, I think this opens up several challenges. Some of them were also mentioned earlier in the discussion. For example, who gets into the network and so on. And here I think what has been done with Scion can provide some experience. But yeah, once again, on proof of transit attestation, this would be maybe an additional step. But what we see is that the basic path awareness is okay enough, but it can always be made better. That's it.
Thanks.
Okay, thanks. We're going to have to accelerate because I want to get to the questions. Dave?
David Skenazy, security enthusiast. So I think, I mean, this echoes some of what other people have said. The key use case here of the La Clément is not met by this solution. And we're like, if we're saying that the problem is our customers are asking for this, that's not a good enough reason to do work at IETF. And if what we're saying is it's regulation, then I would like some demonstration that this makes a regulator happy. Because using a VPN might make the regulator happy. I hear we have a few of these IETF. There's one running over HTTP whose name I forget. And otherwise, will they be happy by the problem that Cullen mentioned, where you splice the fiber? Like, this doesn't seem to solve the problem to me. That combined with the fact that the architecture doesn't seem to work, based on Eric's point, tells me that like I really don't see a path forward for this. Thanks.
Thanks, Dave.
I've got just a quick answer on the policy part. I think you are familiar with Google, GDPR, you will have a few answers. The VPN is not enough because there is no visibility on the path, and this is something that some regulators want. Okay, as for the ERC part, to be discussed, I disagree, obviously, but up to discussion.
So since you bring up GDPR, yeah, I know a thing or two about that. I'm not a lawyer. And no, exactly, we're not. And there's nothing in GDPR about where the packets go on the path. GDPR is about sharing data to places you're not supposed to. So that's your point about GDPR needs a citation.
Okay, that's fair. So at this point, I'm going to close the queue because we only have 9 minutes left. We've been having a lot of discussion back and forth and trying to understand and getting feedback on both sides. So I think it's time for us, the chairs, to get a sense from the room whether, I'm going to ask the first question, is the problem well understood before we can get to a working group? So hopefully you guys can see the poll. So ADs, you're listening and, okay. You're watching.
The poll's not showing up for some people. Oh, maybe it is showing up for people, but give extra time is my only comment.
How many people are on? 140, okay. Okay, we only have about half of the participants responding, so I'm going to give it a few more seconds. Wake up.
So this is Hank. If you have not scanned the code, you can't vote. Just highlighting.
So 80, 90. All right, I'm going to stop and I'm going to count to 10 and I'm going to close the poll. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's kind of rough. So let me ask the next question. I can't type a whole lot, so I'm just going to ask the question, is the problem tractable? Meaning, do you believe the problem is something that we can solve? Okay, so It's funny, it's like theater time. Yeah. Oh boy. Okay, this time I'm going to count to 5 because I think it's slowing down. 1, 2, 3, 4. What's that?
Because they already scanned their QR codes the last time.
So consensus is, you want me to ask the next one?
Sure, why not?
Quick question.
Yes. A little difficult for me. I don't know, tractable means easily doable or doable.
Well, that's why I clarified, because I didn't want to type. Is it doable?
But somebody may be
Do you believe that we can solve the problem? That's the question. Sorry, that would have been faster to type. Okay, let me ask the next question. Is IETF the right venue to solve this problem? All right. That's very interesting.
That one's easier.
That one is easier.
For some definition of easier, yeah.
It's like we're kind of 50-50 as to whether we can solve the problem, but people believe we can.
We don't want anybody else to solve the problem.
That is really interesting. Yeah.
Is there a fourth question?
What's that?
There's another question, right?
Okay. So let me call that one. And then the next question is, so I'm going to ask it in 2 parts. Do you believe, okay, forgive if I have typos. We should create a new working group to address the problem.
You know how to ask for that, right?
Yeah, that's why. Yeah.
Mine hangs all the time. I don't understand what's going on.
Boy, we're like down the middle, guys.
Right.
Okay, so let me ask the next question. The last one is the proposed charter sufficient? I want to ask, do people agree on this proposed charter to form the working group? So let me see how to type that. Do you agree with the current proposed charter to form NASR as a working group? Okay. All right, we're at time.
You are at time.
And
one's-
so the current charter, so
Current
there's
charter's
like
needs
kind of,
to be tweaked at least, right?
Yeah.
So you can't put the summary up, can you? No.
a summary.
Like you can see in MeetEcho, you can see the summary of all of the polls. You can. I don't think you can put it up.
I don't know that I can do that. I can't.
If you close the last poll, then
Yep.
they will all show.
Oh, and then,
Well, you can see it in MeetEcho, but she can't display it on the screen.
I can't display it. So, need direction, esteemed AD?
So I do think you have more work to do. I don't think it's clear. So you've got, the first one was, do you understand the problem? And there was a little bit of consensus, right?
A little bit of consensus. It was very rough at best, and we didn't, I mean, the consensus was more towards the no, for the problem being one that's feasible.
Is it
doable.
trackable? Then it's more no, but it is still pretty 50-50.
It's very down the line, but people are like, yeah, we should do this in the
We don't
IETF.
want, and we don't want it done anywhere else. And we
Exactly.
don't like the charter.
And then it was kind of like 50-50 again of we should create a new working group as opposed to trying to find another, fit it in another working group.
And my other question, and we are at time, and I'm sorry, but my other question is it actually an indication that this is not fully baked yet? And that we should let the proponents continue to work on it, and they should also take as much of this to RATS as they possibly can to get more of the RATS stuff in line before they finish baking the pie or cake. Depends on what you like.
Did you, I mean, we're at time. I can,
you are.
Do you want me to try and ask that? I mean, we still have people.
I don't know.
What's that?
I think we can take this to the NASR list, can we not?
Take it to what?
To the NASR list. No?
I mean, so here's the reality as the chair.
Yeah.
We have a very small group of mainly the proponents
Right.
that are participating in the NASR. So all we're going to get are the proponents, which is a handful of people.
Right. So I would like to see, from a responsible AD point of view, given the way that the polls played out, I would like to see RATS utilized as much as we can. And then I would like the proponents to work on, I mean, they've got things that they can't do. They can't, and I don't know whether we'll ever be able to do them or not, but I think they need to work on the architecture of this. In addition to what I'm thinking about there is the proof of non-transit. The other part of this that I think needs to be worked on is to think about, and I know they're not talking about implementations, but in fact, implementations, if nobody's going to implement this, then I don't know what we're doing, right? And that's, how do you verify, if I get a hash, how do I know it's the right hash, and how do I know it's the proper hash? And maybe RATS answers that question for me. I don't know.
Yeah. Yeah, I mean, the next set of questions would be, if we formed the working group, who would actually be the authors, who would actually implement it and deploy it? Those would be the next set of questions.
But implementation.
Right.
Thank you. Okay. That's a fair point.
We didn't really have strong
We
consensus.
did not have strong consensus. I don't think it's worth the time, expense, and of forming a working group, given the consensus or lack of consensus that we have.
Okay. So what I'm hearing you as AD is we will not form a working group.
Right.
The
No
proponents.
working group. Proponents are welcome to go to RATS if they would like to. Proponents are welcome to go to PanRG, Spring, talk to routing. All of that can happen, right? But no working group.
Okay.
Fair? I mean,
Well,
maybe not the answer you want, but that's given
Yeah.
given the lack of consensus, I think that's the answer you get. Sir, too bad.
I think that is about right.
Are we allowed to propose rechartering of other working groups to include work? Like say I2RS was closed.
You could try.
Question 2.
Sorry, I'm not the AD.
Who did I2RS belong to? That's why I'm asking. Is it a security? You can ask for that to be reopened if you want to.
I think I2RS.
There's no reason why you could not ask for something to be reopened if you want to reopen something. But you have to have,
I2RS
you have
was
to have
security.
a compelling reason for why you want to do that.
Okay.
You can also ask RATs if they want to recharter to have your stuff in it too.
But I think the conclusion, just to close this out, is AD guidance is we do not form a working group. As NASR, the proponents are encouraged to figure out how to find another home. My recommendation would be, we've heard the feedback and the concerns from the tractability, scalability. So there are some questions, I think, that would help it move forward if those were taken under consideration. But again, given that it was down the middle, it goes to, we could take the work and split it into the different working groups as another option. So this is to say it's not closed, we can just explore other options. Right?
Exactly.
Okay. Thank you, everyone.
Thank you.
Apologies for running over, but it was important to go through. All right, thanks.